Let me talk in this video about all the things that you do to solve an inclined plane problem like this. So here we've got this 3.52 kilogram mass. It's on the inclined plane. We know the angle of incline. We know the coefficients of static and kinetic friction here. And we're answering a pretty complicated question, right? We want to know what force in what direction will make it accelerate and slide down the plane at 2.5 meters per second squared. Now, before I solve this, I've got to calculate a bunch of things. Okay, the first thing I want to do is figure out the parallel component of Earth's gravity, right? In general, that's mg sine theta. That is, it's the weight, m times g, right? The force that's straight down times the sine of this angle there, right? So if that angle is 0, then of course sine of 0 would be 0, and we would have no force parallel to it. And if it was 90 degrees, all the force would be parallel to the plane, right? So let's type this in here: 3.52 kilograms times 9.81 newtons per kilogram times a sine of 42 degrees. And making a quick check to make sure that we're in degrees. Indeed we are. I can type that into my calculator: 3.52 times 9.81 times sine of 42. And I get 23.106. And that ought to be enough precision for us, okay? So that's step one. The second thing I want to do is figure out how much of it is perpendicular to the plane, how much of the weight, and that's going to be mg cos theta, right? So that's going to be 3.52 times 9.81 times the cosine of 42. So let's do that again. I'm going to go second entry. I'm so lazy, I'm going to go back and hit there, and that's 25.662. Okay, now I'm not going to do anything with this. This guy really isn't a player along the plane. It's just that this becomes, if that's the component of gravity into the plane, this thing here becomes the amount of force that causes the friction. This becomes the normal force, unless there's something clever going on, like somebody's pushing down on this plane block or lifting up on it. So to find the force of friction kinetic, which is if it's sliding, right, this is the guy that we're going to use, is the kinetic coefficient. To find the force of friction, the kinetic force of friction, that's mu times the normal force, and this is the normal force. Okay, so that's going to be 0.37, right, times 25.662. Okay, so the number that's on my calculator, I'm just going to go times 0.37, and I get 9.495. Right? Okay, so that is, now we've got these guys are the players, right? Along that plane, if it's sliding down the plane, the friction force will be up the plane of 9.495, right? This is our force of friction. So friction always opposes the sliding, right? Opposes the sliding direction. Okay, so since we're sliding down the plane, this guy's going to be up the plane and positive, right? Parallel force is easy. Parallel force is always down the plane. So let's draw that guy, right? 23.106. That's our parallel component of the gravity. It's not another force. It's just a thing. That's going to make that thing negative. And then there's going to be some unknown force. So we're just going to go, which way is that force, right? That's our unknown force. So now we set this thing up. We've got all of these things. Our expression for F equals ma looks like this. Okay, unknown force minus the parallel force. Let's see, plus the friction force, because this guy's up the plane, right? And those are all the forces there are, right? So here's our parallel force, here's our force of friction, here's our unknown force, right? And then that equals m, which is 3.52, times the acceleration, which is, let's see, accelerating down the plane, right? Doesn't that make it a negative acceleration? Yeah? Okay. So if you look at this thing, uh-oh. Okay, if you look at this, all you need to know about this thing is if you look at that, this that is down the plane, right? The acceleration, we're using F equals ma as our formula here, right? And you just have to add up all the forces. You've got the unknown force, parallel force down the plane, friction force up the plane, equals m times a. And now I'm going to type this into my calculator. I'm going to go 3.52 times negative 2.5, and then I'm going to go minus 9.495, and then I'm going to go plus 23.106, and I get 4 point. If I solve for that force, I get that the force is 4.811 newtons, which is our answer there. Okay, so you've got to do this. You got to find the parallel force. You got to find the perpendicular components so that you can find the friction force, right? So find that, find the friction force, right? And then look at the unknown force. If they give it to you, the unknown force is, if it's up the plane, it's positive. If it's down the plane, it's negative. Parallel force is always down the plane. Friction force always opposes the direction of slide. So if you're sliding down the plane, it's positive. If you're sliding up the plane, the friction force is negative. Okay, it just opposes the direction of sliding. This guy is always down the plane.